Okay, here we go. We'll take a look at the molarity worksheet 6.7. First thing you must do is memorize the molarity equation. You need to have that in the bag. And then if your algebra doesn't fail you, you can realize that molarity times volume will always give you moles. So in this first problem, we're given a volume, we're given a molarity, so a simple multiplication will give you moles of sodium phosphate. That's not the question, though. We need to know the mass of sodium phosphate. So we'll need to add up our molar mass. And then from previous in the unit, we know that moles times molar mass will give us mass, which is the question, the answer to the question that we're after. Now, there's a second question here that asks, when this chemical dissolves, what is the molarity of the sodium ions? Well, it's important to realize that when sodium phosphate dissolves, we get 3 sodium ions. It's like a buy one, get 3 particles. So the molarity, which we knew in the original problem, times 3 sodium ions will give us triple the molarity of the sodium ions swimming around the solution. So there's 0.35 molarity of the chemical, but there's triple that, 1.05 molarity of sodium ions. Right then, on to question 2. What is the molarity when 8.75 of ammonium chloride is dissolved to produce a certain volume of solution, 200 mils? Well, you need to be able to write the formula correctly and add up its molar mass, which will then allow you to take grams mass, the mass in grams, divide by the molar mass, to be able to know that we are going to be putting 0.0655 moles of this chemical into our 200 mils. That allows us to plunk those numbers into the molarity equation. This one here, 200 mils there, which of course we change to liters, and solve in the end for our 0.328 molarity. Third question, push it all the way to the top. Number 3 asks a slightly different variation on the same theme. You're told what mass of the chemical you can use and what concentration you want to make up. So what size flask should we use? Flasks don't come in all sizes. I chose numbers that would make this work out. So we need to know the formula and the molar mass of sodium hydroxide. Then we can take our mass, 10 grams, divide by molar mass, to know that we need, or we have in front of us, 0.25 moles of sodium hydroxide. Since we know that we'd like to make up a 1 molarity solution, plunk those into the equation, solve for 250 mils that we need to produce, which is of course 0.25 liters. Now it also asks how many moles of each of the ions are in the solution. Well, in this compound, when it dissolves, it produces 1 sodium and only 1 hydroxide. So of course it's the same. There really should be a 1 there. So it's a 1-to-1 ratio. So we'd have 0.25 moles of sodium and 0.25 moles of hydroxide ions. And then on to the next one. We can proceed to number 4. This is a little bit different. Now we need to be thinking about using the dilution equation because we're starting with volumes of original chemical, not masses. So with the molarity equation and you knowing that molarity times volume gives moles, when diluting, moles of the concentrated chemical will equal moles of the diluted chemical because you put them into the container, you would just add water, the same amount of moles of chemical is still there. That allows you to combine 2 molarity equations to give you an MV equals moles for equal to the other MV, M times V equals moles. So from the problem, we could plunk in our values and wanting to know how much of the concentrated material we'd need to start with. when diluted out to 500 mils, you'd need to start with 12.5 mils in order to achieve this 0.025 molarity. Note that I use milliliters, not liters, since in the dilution equation, volume is in the equation twice, unlike in the original molarity equation, it's there only once. You can use milliliters because they would effectively, volume-wise, cancel each other out. Remember, however, when using the molarity equation only once, like here, you must always be in liters. On to number 5. Number 5 is asking us what the concentration would be. And so if we're starting, again, we can use the dilution equation. We can see that we're starting with a molarity of 12. We're going to use 10 mils of it. And so we're going to dilute it up to 2 liters. 2 liters is, of course, 2,000 milliliters. That allows us to solve for a molarity when it's diluted would be 0.06. Again, we could work in milliliters or liters. It wouldn't matter. The 6th problem, which is the last problem, I think. The 6th problem asks us how many millimoles of aluminum chloride are present in a certain volume and a certain concentration. Well, if you work in milliliters using the molarity equation, you will come out with millimoles. So simply take our concentration and our volume and solve for millimoles of the chemical that we're dissolving. Now, we'd like to know how many ions of each one, again remembering that when aluminum chloride dissolves, it breaks up into 1 aluminum and 3 chlorines, or chlorides, I should say. This is like a buy one, get 3 chloride ions. Of course, there's 4 ions total. So if we know that we have 2.5 millimoles of the chemical, that will be 2.5 millimoles of aluminum, but times 3 for chlorine, resulting in 7.5 millimoles of chloride. There you go.